Deep learning has taken the world by storm, but training deep neural networks can be tricky. The vanishing gradient problem is a common issue that hinders learning in deep network. So today we will explain this vanishing gradient problem in easy to understand terms. Let's get started. So what is vanishing gradient? So imagine you are trying to navigate a dark and narrow staircase, and at the bottom there is a small flickering candle that is only your source of light. So as you climb the stairs, the flickering light from the candle get dimmer and dimmer until it's almost imperceptible at the top. And it is very difficult to determine which direction to turn, and you are left wondering if you are making progress or not. This is similar to the vanishing gradient problem in machine learning. In machine learning, the gradient is a measure of how much the output of model changes when the input is adjusted. During the training process, the gradient is used to update the model's parameter to minimize the cost function. However, when the gradient becomes too small, the model can become stuck, unable to make significant improvements to its performance. This is known as vanishing gradient problem. So to illustrate this concept, consider a simple example, a neural network with three fully connected layers. Now the first layer takes an input and outputs a transformed version of the data, which is then passed to the second layer. Then the second layer processes the transformed data and passes to the third and final layer, which produces the model's output. So during this training, the gradient for each layer are calculated and the parameters of the models are updated based on those gradients. However, if the weights in the first layer are too large, the gradient for the subsequent layer will become increasingly smaller and smaller, eventually vanishing. This means the model will have difficulty learning and improving its performance, resulting in suboptimal results. So to summarize this, we can say vanishing gradient problem occurs when the gradient becomes too small during the training process, preventing the model from improving its performance. And this is a common challenge in deep neural networks, and various techniques such as the rectified linear unit and initialization have been developed to mitigate this issue. Now to demonstrate this vanishing gradient problem in Python, we'll use a simple feed-forward neural network with two fully connected layers. So here we will train the network to classify handwritten digits using a popular MNIST dataset. So let's first import the necessary libraries, then load the MNIST dataset. Now let's define a feed-forward neural network with two fully connected layers. Also, we'll use the sigmoid activation function and the cross entropy loss. Note that we are using a small learning rate to exaggerate the vanishing gradient problem. Now let's train the neural network with a batch size of 5 and a small learning rate of 0.0001. So this will exaggerate the vanishing gradient problem, right? So in this example, we have used a small learning rate to exaggerate the vanishing gradient problem. And the training cost will increase over time as the gradients become smaller and smaller. So to address this vanishing gradient problem, we can use techniques like large learning rate using rectifier or sigmoid activation function. Thank you.